And so with that, with the next half hour or so, we're going to turn our attention to the demonstration of the software. And so I'm going to pull over my existing HACTool file. I realize that not everyone has seen HACTool. This may be your first time seeing the software. So just spending a few minutes to introduce you to HACTool and what you see on the screen in front of you. And then we'll get into the specifics that I was talking about. So this is HACTool whenever you load it up and you add in a map of your choosing. It could be a plot plan of your entire facility. It could be a plot plan of a specific unit. This example that we have right here is a compatible DWG file that was created by BakerRisk for internal training purposes. You see the customary equipment tags, equipment objects. It's been scaled. It's been added to the software. Unfortunately, we don't have time to show that inclusion process, but it's as easy as clicking on the file you want to upload. If it's compatible, it shows up on the screen here in front of you. I will say it is important to note that HACTool has the ability for you to add multiple maps to the file. And so if you can think with me for a minute, you have an overall plot plan of your facility. You can add that. Maybe it has multiple process units in it. And then you can overlay on top of that map of the facility individual plot plans of a specific unit, such as you see in front of you. And that allows you to, if you add any release sources, and it's those sources that are going to generate our classified area boundary and our requirements there, any release source that you add to one map, if it's properly overlaid on top of each other, it gets added to all the other maps in the stack. And so you can generate contours for a unit and also for the entire facility if you set up the file that way. But looking at HACTool, just getting familiar with the layout, on the left-hand side, we have all the different buttons that allow us to interact with the map. And so right now I'm using the hands tool, which allows me to drag the map where I want it to go and zoom in and zoom out. There are other buttons that we'll touch on throughout the course of this demonstration, such as buttons that allow you to move objects, edit objects, even select an entire area of objects and move them or duplicate them. Are all capabilities of the software. On the right-hand side, we have the specific objects that you can add to the map. So everything from add a release point, so this could be a pump seal or a compressor seal or a PSV that you want to add to the software and have it calculate that classified extent distance from. To, as Mitchell was talking about, you can add buildings to the model. And those buildings, what they do is they serve as a potential boundary. So if you have a classified area in the building and you know your walls are vapor tight, you don't want that classified area boundary to draw outside of the building because the wall would confine the classification. And so the building allows you to play with the geometry and adjust based on your specific application. Other objects that we won't have time to get into are building stacks. We know that the location of fresh air intakes is very important when it comes to complying with area classification. Walled off areas, doors that maybe have a frequency of opening and closing are different parameters you can get into for classifying your area based on the frequency of that opening or closing. Walled off areas, which we'll take a look at for our dust release source. Area release sources, so if you have a dike or a truck loading area, that could be not just a single point, but an entire area. An ignition source, which we'll take a look at, which is that gap analysis, that stage 5 of building the software. Structures, even roads as well. And so a lot of objects, we'll look at some of those here in a minute. But looking at the top, we have the data, the inputs into the software. So everything from the maps that we were just talking about to the components. So the components are pulling from the DIPPR database for the chemicals that you can add to your model to run in your analysis. Everything from hydrogen, propane, decane, methanol, anything that's in the DIPPR database, it brings in and allows you to use and to model, as well as auto ignition temperatures and other information as well. Buildings, we've talked a little bit about the addition of buildings. Sources, we've talked about those, and then ignitions, we'll see a few examples of those. And so now what I'm going to do is I'll come back to the top of our screen once I add some more inputs to the file. And so what I want to do is look through the different objects that have been added for this demonstration purposes. And so each one of these orange crosses or crosshairs is a different release point that we'll look at. This rectangle right here is a building that I've already added. And this red object is a walled off area. And we'll see how that interacts with our contour. And then over here on the right is our ignition source, which could be a light switch, could be a motor, anything that needs to comply with the area that you're putting it in. And I'll start off by saying, if I didn't already say this before, that I am currently showing the NFPA version of the code to really highlight those custom contours. And then I will be sure to save some time for the IEC version of the code. We'll look through the IEC setup, which is very similar from the NFPA. And so for starting off, I'm going to click on my Edit tool here on the left. I'm going to select this orange object. And what pops up is our release source input screen. And so this is where you can add the specific parameters that you want this release source to be based off of. Remember, we're going for the release of flammable and combustible materials. We need to know where it is in space. And we need to know what temperatures, pressures, what material is being released from that point, as well as elevation. Now, the NFPA 497 logic that's installed into and developed into this code, again, is very prescriptive. It's if you have a small, medium, or large release, here's the recommended extent distance. And I'm not going to show that feature of the code since that feature has been in the code for a number of years now. What I really wanted to highlight is that the custom source, so taking the prescribed distance and changing it based on sound engineering judgments if you have an application that warrants it. And so this is our input screen for the release sources. We've got a custom name for the release source, and we've got a type, an equipment type. And so here, this is everything from that pump seal to compressor seal. And a lot of these for NFPA 497 have that predetermined extent distance for your Division 2 boundary or your Zone 2 boundary. But what I want to highlight again is the custom source. And so I'm going to keep it selected at custom source. HACTool is a wonderful database. If you invest the time to build it out for your specific process and unit, you can add tag numbers, what PFD this equipment's coming from, the description of the equipment, and even observations. You can have your team take a photo of the equipment out there in the field, write notes about its maintenance history, all combined together in this single source menu. You can do this for each piece of equipment on site to generate this source database, release source database for your facility. But the main input for the custom source for NFPA is really this screen right here. And you can see it allows the user to pick a 3D shape, cone, cylinder, rectangle, or spherical shape, and to give it different dimensions so that you are literally drawing the custom contour in three-dimensional space based on your inputs and your knowledge of what the classification should be. You can then define, is it Division 1, Division 2? And then you can define your material group, A through G, as well as finishing off the auto ignition temperature for your T code. And so with this, really the goal again is to allow customization, based on sound engineering judgment, which relies on the user, but really to customize the HAC contour in situations that warrant it. And I mentioned this is just for a specific point, so this is really starting with a point in drawing the 3D shape. If you go to the area release source, that's where you can draw more of a polygon shape if you have more of a special case, more of a polygon object dimension, we'll say, out in the field. So there's that option as well. And so if I go to run the software now, if I want to say I've added my custom source, let me generate my HAC contour. It's as easy as coming up to contours, clicking on classification. It pulls up the full list of all release sources you've added to the model. So you can run all of them at the same time, and HACTool will merge the classification contours relative to each other. But for now, I'm just going to click on our custom source and tell the software just to run that one. It'll ask what contour sets do I want to run. So I could run only Division 1 contours. I could say, HACTool, show me all Division 1 contours and just run those. So you can quickly see those locations, what sources are driving those. For now, I'm going to click our Division 2 default setting and press Save. And you see there, what it's done is it's looking at the inputs for each source, in this case, just one source. I told it a 10-foot Division 2 contour, and you can see it is now drawing our spherical 10-foot Division 2 contour here on the screen. And if I wanted to change the cross-hatching pattern or color, or even group, so that it is only group D, let's say, I could come up here to Options, go to Contours, and here's where I can change what contour sets are composed of. And so this is the one that I was using for our demonstration to draw all Class 1, Division 1, and Division 2 contours, BCD. I click on this palette over here. You can see I can change the cross-hatching pattern as well as the color to a custom pattern and color of your choosing. Looking ahead, we see that there's a Class 2 for combustible dusts contour already defined. And so in a moment, we'll run the dust contour as well. It's a very similar process of defining the contour hatch pattern and groups that you want to have drawn. Before we move to the dust side, it is important to note that HACTool can also show this in three-dimensional space. So there's a button over here where I can toggle between two-dimensional and three-dimensional view. So here you see whenever I move to 3D, we still retain our foundation, our DWG file, which shows our plot plan. You can see our building and our dust inputs over here on the right, which we'll get to here in a minute. But then you can also see the three-dimensional spherical custom contour that I've drawn here, and the bubble that results from that Division 2 input that I gave it. So I'll go back to our 2D top-down view here. The other thing, you can also see the contour is a cross-sectional view. So if you can imagine, if you had a lot of these custom contours, maybe they're pump seals, PSVs lined up all in a row, and you say, well, I want to quickly see what the side view is of this area. There's a button here on the left called Show Cross Section, and it'll say to click on a few points on the map. What I can do is drag and drop, and then you can see this is a side-on view, so no longer looking from top down, but looking from the side. Here is the classification along that line that I drew. And it's just showing one really source here because that's all I added for this demo and I'm showing here. But if you had a whole slew of customization contours or other contours, this would give you a quick side-on view of that classification. In terms of reporting now, so if I wanted to export this to HTML or CAD, I'll start by showing you the CAD export. So if I come up here to contours and say, draw this file to DWG, it'd be a very similar process where it'll ask you what sources and what contour set to draw. And then what it exports is a DWG of that contour. And so provided you give the software an appropriate and acceptable DWG, what HACTool does is it overlays the contour on top of that DWG. So it does not convert PDFs or JPEGs to DWG. It relies on the user to provide that file. The file is accepted into the software such that you can now draw the contours on top of the DWG format. So here you see that 10-foot sphere, Division 2 contour, and then the legend that's associated with it. And then you could take it into the CAD software and adjust it on the CAD side to add more details there. In addition, the other export that I'll show is if you come to Reports and Contours, then you can define a custom HTML report off of this specific scenario. And so if you go through that process of clicking Contours, it asks you for an area to define. And so I've drawn this red box around the area I want my report to be based off of. And I press Create Report. And now it's asking me for some inputs into that report. So what contour set do you want to generate? Can be chosen here. Again, I could just have a report of all Division 1 areas, maybe all Group B, hydrogen and other related releases. Or I could do dust and flammables together. I can add notes, so I can add custom notes to the export. In the typical drawing, you have revision history and you have logos, and so you can even add revision history and keep track of the revision history of the drawing, which is essential and critical for maintaining any drawing on site. If you go through that process, what comes out looks something like this. Oops, sorry, one second. Pull this one over. Give me 1 second to open the file. There we go. And so this is the HTML report that can then be saved as a PDF. So if you prefer it in PDF format, you can take your HTML and save it as that. And so what we have is a map of the plot plan here. We have the release source that we are looking at, the custom release source, area classification, as well as the legend shown here on the bottom right. On the right-hand side, this is where any notes that you add to the file would be shown here, that the text that you can add. You can say that this drawing was based on NFPA 497, version XYZ. You can change the site name and site owner. And then if we had specific materials, I was just showing a custom contour, but if our releases were based on hydrogen, methane, etc., they would be, the chemical properties would be listed here. And we'll see that actually in the IEC version output for that demo. And then at the bottom here, this shows the side views or the drawings from 497 that are being used to generate these contours. And so I'll run the dust contour here in a few minutes. But this report is saying that this Class 2 Division 2 area is based on this drawing from NFPA 499. And so you can see, we'll see a 10-foot spherical shape on the dust side, and the report gives you the corresponding side view from the standard document recommended practice. You'll see there's not one for the custom contour because that was individually defined by me, the user. But if we had selected pump seal, compressor seal, PSV, those other equipment types for this source, then we'd have a additional side view from 497 to show you the corresponding side view from the 497 document. And finally, at the end, I didn't add any drawing numbers or titles for this demo, but that would go here, as well as the revision history that just grows as you add more to it. And so those are some of the main outputs from the software. Ultimately, the software is a tool to be a database for storage of information, but also a tool to help you generate these hack drawings that you can use and give to your electrical engineering team, engineering teams, and other users. Coming back to the software itself, we've been talking about the custom contour. Now I want to shift a little bit to the 499 inclusion into HACTool. And so what I'm showing over here just briefly is a release source. I'm going to come and click on Edit Object. It's asking, do I want to edit the building that I just clicked on or the dust release source? Because both are on top of each other. So I'm going to click on my dust source. And you can see the input screen is very similar to what we saw for the flammable NFPA 497 release source. You have a custom name. You select your equipment type. This time we'll say dust. Give it a tag number, PFD, or description is optional. It just adds value. You can add in observations. And then there's a new tab here called NFPA Dust. And so here's where you can select, based on the NFPA 499 guidance and logic there, what kind of equipment you want to model. Is it an open or enclosed vessel? Enclosed? Is it storage in bags, drums, hoppers? Is it multiple pieces of equipment? So our purposes for our demo, we'll select enclosed. We know from our demonstration material, it's a group F material. And we're defining a Division 2 primary hazardous area classification contour and then the secondary contour we'll call is unclassified. So we know in 499 and 497, sometimes there's a need for a Division 1 followed by a Division 2 contour, and then you get to unclassified. And sometimes you have situations where you really have an enclosed system, and it's really just a Division 2 contour in the area, and then the surrounding area outside the Division 2 is unclassified. So this allows you the flexibility to do both, either or, based on your specific setup. And so for 499, we have our inputs here. And what I've done is I'm highlighting that feature of adding dust sources, but also I've added this wall object here, which is a non-penetration wall. And so what it's going to do is confine the classification to around the wall. And so I'll go ahead and run that and show you what I mean there. Make sure I select the right contour set. Now I'll zoom in here. And so that you can see the classification a little bit easier, I'm going to hide buildings. So that just gets rid of my building object from the view. And now we can see our classification for the dust source. And so you see it's a Class 2 combustible dust, Division 2 area as we defined, and group E, F, and G. Again, I can go into the options and make that just group F, but for our purposes, we're keeping it all together. And you can see that the contour is drawing that 10-foot contour that we saw from the export, the report, and it is now recognizing that wall object to limit the extent of that classification boundary, realizing that the physical combustible dust will not get through that wall, and it goes around that wall in some capacity. The contour is also being limited by the building. That is an option. And so I've told the building to limit the contours. It's physical walls, physical obstructions is what we're going for there. And then similarly, we can turn to 3D space, zoom in, navigate around to see our 3D shape based on the geometries that we've added to the software for our dust source. I'm going to keep moving on due to time's sake, but that was highlighting the custom contour feature and the new dust feature that recognizes walls and physical obstructions that the user adds. The only other thing I wanted to mention with the NFPA version, this is an NFPA and IEC, just taking the time to highlight it now, is the addition of ignition sources. And so we know, or I like to say, there's two big parts to area classification. One is, what is the area classification for this process unit in the area that I'm working in? And then it's part two, does all the equipment that is in that area, does it meet the classification? So doing your equipment audits to make sure that you're in compliance to minimize the ignition probability. And so what I have over here is a ignition source. I'll click on my edit tool again. So I can edit that one. And you see I can give each ignition source a custom name. I can define a specific type from motor to switch to circuit breaker, transmitter, actuator, etc., etc. I can add a tag number for this specific piece of instrumentation. This is something that we'll run a report on shortly. I can say if the tag number is missing, unreadable, or inaccessible, which helps with your audits of documentation and equipment. You can define a manufacturer, a model number, give it a location, even talk about certification. You can define what that piece of equipment is rated for. So if you get a pump and you say it's rated for Class 1, Division 2, Group BC, you can select BC. You can select the IEC type, NEMA enclosure type, T rating, all the relevant inputs that you would need to properly define this and consider this ignition source out there in the field. As well as similarly, observations. So the whole purpose of HAC is to minimize ignitions and protect equipment and personnel, right? And so whenever you're adding ignition sources, maintaining those ignition sources is crucial for this whole process. And so with the observations tab here in the ignition source screen, you have the option to select, is it damaged? Is this piece of equipment corroded? Is it missing conduit seals? And it should have conduit seals. Are there missing enclosure bolts? To help you track what are my defects out there in the field and what needs to be fixed in order to comply with area classification and minimize those ignitions. And to help with that, I will cancel out of this input screen. There are additional reports here in the Reports tab. And so the first report that I want to run is what's called the Labels report. And so if I click on the Labels report, it takes a look at all the ignition sources that I've added to the file, and it gives me a list of any of those ignition sources that had a missing label, an inaccessible label, or an unreadable label. And so for our inputs in our demonstration here, we said for our input that this label is missing yes. And so this can quickly tell you which ignition sources need to be fixed and looked at for further information there. You can also run it on the defects input. So if I come up here to defects, it does the same thing, looks at all the ignition sources, and this is the missing enclosure bolts, broken glass, damage, conduit seal missing. It gives you a report on which one of these need to be looked at as well. There is additional reports that look at, it's called the gap report and the T rating report. These are currently being developed by BakerRisk, so they won't be ready at the start and the release of this today, but they are in development. And what these do is they take a look at the classified area boundary. So looking at all of your classified areas that you've added to the software, and it does a gap analysis. And so it'll tell you if you've defined this ignition source as it is approved for Class 1 Div 2 Group B, but let's say it's in an A area or it's in a Division 1 area, it'll flag that and give you a report to show you which ignition sources are not compliant in that classified area boundary that is being drawn on top of it. And then similar for T rating and T code, comparing the contours T code and T rating based on its flammable material, and then the ignition source, what you've put here, comparing the two to give you a gap analysis report. And so the hope there is that this tool aids you in both the development of classified area boundaries, as well as the generation of those reports, understanding the area classification, and then maintaining a database where you can house both flammable, combustible dust and ignition source information to give you a complete package of what you would need in order to maintain and develop a HAC program for your facility or your equipment. Time is running short, so I'm going to go ahead and switch over to the IEC version of the demo and walk through some of the additions that we've made there. And so what I'm pulling onto the screen now is the same HACTool software, but now I've switched the parameter to run the IEC version, not the NFPA 497 version. And so first and foremost, you can see it is pretty much exactly the same layout. It's the same look and feel. I've added my map, but now I have two different release sources that we'll cover here today. For our example on the IEC side, I've gone ahead and added one hydrogen release and one hexane release. And so I'm showing you here, I talked about this at the beginning of 497 version of HACTool, NFPA. If I click on components here, pulls from the DIPPR database, and I can add whatever components pertain to my study here, and it pulls in the relevant hazardous area classification information, which is a lot more. If you're familiar with IEC versus NFPA methodologies, there's a lot more information to pull in from the IEC version, since we're actually calculating extent distances based on discharge parameters and hole sizes, which is the guidance from IEC. If I click on streams here, I'll show you that one of the releases that we'll look at is hexane at 30 degrees Celsius and 5 bar. And then the other stream that we'll look at is hydrogen at 30 degrees C and 5 bar. And so this is showing you the streams input screen. HACTool can handle mixtures of flammables. And what you do is you add in the mole fraction or mass fraction, the different chemicals. You give it a temperature and pressure at a minimum. It'll calculate the relevant information for that mixture using some mixing rules, ultimately to get you your T rating for the mixture and your group rating for the mixture as well. You can also add those streams in a table format. So if you have a lot of streams, you click on the Add Streams by Table. You can copy and paste data in there. You can even add sources by table as well. Okay, so the time that we have remaining in the demonstration, I'm going to click on my Edit Object button and come to our first release point here. And so the first one we'll look at is a hydrogen release from a theoretical compressor seal. And the stream that we're modeling is that hydrogen at 30C and 5 bar. You can see initially that this looks very much the same as the previous version of the code that we looked at, the NFPA version, with your opportunities to add tag numbers, descriptions, PFDs, and elevation, observations such as notes and photos. But you'll see that there are more tabs here on the left, and these are required in order to calculate the extent distance based on the IEC methodology. And so we'll walk through these step by step real quick. So the first tab is the IEC release rate. And so if you know the IEC approach, it really wants you to provide the material, the pressure, the temperature, and a hole size. And based on the calculations in IEC, the formulas, it'll calculate a vapor release rate. And that in turn will help us get to the extent distance of our classified area boundaries. And so for the IEC release rate tab, we have the opportunity to choose, is it a continuous release? Is it a primary release, or is it a secondary release? For a compressor seal, I would hope we would put secondary release source here. The software is automatically saying it's a gas release because we've already defined hydrogen at the temperature and pressure. IEC does give guidance on what hole size to use in terms of our discharge calculations. For now, in our demonstration, we'll use a 5 millimeter squared release hole size. We're not dealing with liquids, so we don't need to add in a flashing rate, wind speed, or pool size. Those are really inputs we'll see become important on the liquid release side. But then ultimately, this tab is trying to get us to that vapor release rate shown here. And so based on the material and the inputs that I've selected, the IEC calculation is coming out to about 1.8 E-2 kilograms per second based on that formula. Now you see this is a changeable field. So you could bypass a lot of that I just talked about. If you know your vapor release rate, you can override this cell, and whatever value you put in here will be carried on in the future calculations for extent distances. Okay, so step one of IEC is done on calculating my discharge rate, my release rate. Next step is to look at dilution and availability of ventilation in the area. And so this tab, it is trying to calculate, based on the IEC framework, what zone is this classification going to be? Is it going to be zone 0, zone 1, zone 2, negligible extent, et cetera, et cetera. And so the options here are really trying to get what is the degree of dilution for this release, which has to do with the airflow patterns. Is it an obstructed area? Is it inside, outside? And it's asking the user to select the degree of dilution. And what it'll do is it'll advise on what the degree of dilution might be based on IEC calculations. So you can see some values up here in this graph that is provided by IEC. The software is saying this release falls in the medium dilution range, but all for customization. If the user has sound engineering judgment to say, no, it should be high dilution or low dilution, you can change that option here in the software. So I'll keep that at medium for now. Dilution availability is also important whenever it comes to calculating the zone. And so you can select between good, fair, and poor, which is all from the IEC methodology. And of course, is the ventilation working just determines if that gets credited or not. And so we're dealing with an outdoor release, not obstructed, medium dilution. It's pretty typical in terms of degree, and availability is good. So the logic is saying zone 2 for this specific scenario. The last thing is to put it all together and draw it. And so We have our vapor discharge rate. We know it's zone 2. The last part is how far does it go and what shape does it take? And so again, coming to the IEC figure D.1, this chart estimates the distance to your classified area boundary. And so based on your volumetric flow rate, more or less, the x-axis here, the y-axis is the extent distance. And so you can choose if it's a heavy release, if it's a diffusive release, or a jet release. And what the software will do is it'll look at these different lines from the IUC. It'll take your X value that's been calculated, and then it'll go find the line that you've chosen, and then generates the corresponding distance to that classified area boundary. So you see here for our specific case, I've said diffusive because it's hydrogen. Based on our X value, it's saying a hazardous distance of about 3.16 meters. Again, this value can be overwritten too for the sake of customization. So you can override that value, which leads to the custom contour approach essentially for IEC as well. So that calculation is all done in the software. The last thing to do is to give it a shape. So IEC Appendix A gives various shapes that you can choose from in order to draw your classification. And so some of those are shown here on your screen. So we're going to choose gas or vapor at low pressure, call it a sphere, and then it's pulling in that R value, that distance value that we just calculated using the IEC hazardous extent calculator there. And then once you've done that, you're ready to run your contour. And it's the same process as before. Contours, classification, choose the release sources I want to run. Make sure I select the right contour set. Press save. And I'll zoom in on my hydrogen release. Can move to 3D, and you see the spherical 3-meter radius, 3.16 hydrogen release, zone 2 release source, and a drawing that we've produced there. And then similarly, I can export to DWG, can export to HTML. But before doing that, I will just briefly show you the hexane release. Come here to edit object. The same process for liquid releases. Give it a unique release source name. This time we'll say it's from a pump, since it's liquid. Give it that stream, a hexane that we defined. Come down to IEC release rate. And it's the same process, only now for the liquid release side, IEC wants you to provide a flashing rate, how much will vaporize or flash whenever it's released, the wind speed and pool size values, so that IEC can use that in its calculations of the overall vapor release rate. So there is a bit more manual input necessary when it comes to liquid releases. You know that if you're familiar with the IEC version, and that gets added into the calculation for the vapor release rate there. Similarly, I select my degree of dilution. So based on these inputs, low dilution, zone 1. This time I would select my heavy form of release. So now it's using the new calculated X value to go up to the heavy line and then over to get my extent distance of 7 meters radius. And then last, for flammable liquids, IEC recommends figure 8.5 flammable liquid, and it pulls in that value that we calculated. It does ask for additional parameters such as the size of the pool and the R prime height. So those are all values that the user does need to provide based on their engineering judgment. Then again, as I mentioned, that's running it. That's the setup. And then if you generate the report, it is the same HTML file. It's not scaling here. 1 second. There we go. I just had to bring it over to the right window. Very similar HTML file that we saw coming out of NFPA 497, where you got your plot plan, you've got your classified areas, and the legend shown here on the bottom right. This time, because we did define specific material and material properties, it is bringing in those streams that these release sources are based off of. So here you can see the property data for hexane and hydrogen. Again, I had the ability to generate custom notes if I were to go that route. And then at the bottom here, instead of showing the specific side views from NFPA 497 and 499, because we're doing IEC, which is a lot more, depends on the calculations, it gives you the figures from Appendix A that were used to generate these shapes in the software. So there's our flammable liquid shape, and then our sphere that we use for the relatively lower pressure hydrogen release. Okay. And the last thing I'll say on the software side is, again, just a reminder, if you wanted to change these cross-hatching patterns or colors, IEC has the same ability. Options, contours, class 1, define what zones you want to have run or drawn, define what groups, and then clicking on the color palette here is where you can customize what hatch pattern and then what color you want to have drawn on the screen. All right, there's a lot more that can be said about HACTool, a lot more that we can get into about its features and capabilities. But again, the purpose of this was to really highlight the additions to HACTool, such as the custom contour ability, updates to reports that can be generated, as well as the IEC calculations and their inclusions into defining those customized boundaries for the software.